Hello, welcome back in College Algebra. Today we're going to talk about system of equations in three variables. We talked before about systems of equations, or linear equation to be precise, in two variables. Today we are gonna develop the idea, extend this idea to three variables. So the difference between 2 and 3 is that we have an extra variables and extra equations, meaning that we have to solve the system of equations, as we're going to see in the steps. Differently, we're going to have the solution in three variables. That is, we have x, y, and z. Also, we have to think about that this is three lines, but these three lines are going on the coordinate x, y, and z. So if you think about it, it's going to be three dimensions. It's no longer x and y, but would be x and y and z. We're going to look at this and see how it works. So first of all, the objective of today is, number one, I have to identify a solution of the system of equation. In other words, if I give you a solution, you have to determine whether this solution is a proper solution for the system of equation or not. We're going to learn how to do that. To solve the system of equations, how do we solve that? If you have a system of equation, how can you solve it? Is it the same like two variables or different? This is what we're going to see. The system of equation and application, I'm going to give you one application and we'll see how we interpret this application to system of equation and solve it back. Alright, so let's start by an example about the identifying the solution. So if I give you the system of equations as this, I have my system of equations is, I have 2x plus 5y minus z is 27, and I have 4x minus y minus 2z equals 21, and the third equation 5x, and there is no y, plus 3z equals 19. Alright, so let's think about that. I'm giving a solution, this solution, I want to determine whether the solution 5, 3, and negative 2 is a solution for this problem. So 5, if you think about this solution, this is the value of x. So here's this x, and this y, and this is z. In other words, I have x is 5, y is 3, and z is negative 2. So what I do here is to plug these three values here, and first equation, second equation, and third equation, and have to make sure that this solution satisfies every equation. So let's try that. We're going to go with the first one. I'm going to plug 2 times x is 5 plus 5 times y is 3 minus z, which is negative 2. So how much is that? 2 times 5 is 10, 5 times 3 is 15, minus negative 2 is plus 2. So 15 and 10 is 25, plus 2 is 27. Great. So the first one is correct. Let's try in equation 2 and 3. So equation 2, 4 times 5 minus, what is y? Y is 3, minus 2 times the negative 2, which is z. So I got here 20, and then negative 3, and then negative 2 times the negative 2 is plus 4. So 24 minus 3 is 21. Okay, super great. So one more, and I can decide whether this solution satisfies the system of equations or not. Alright, so the third one, 5 times 5, and then plus 3 times the negative 2. Let's see how much is that. I have 25. 3 times negative 2 is minus 6, so I got 19. Oh, so now I can tell 100% that this solution satisfies that system of equation. So this solution is correct. right? So this is how we identify solutions of system of equations. All right, now, so you are given in this problem the solution. But if I give you this system of equations, how can you get that solution? So this is the second objective that we are working today, is the way or the method that we used before in solving two linear equation or system of equations in two variable, the same as for the three equations. The answer is not necessarily. So we need to extend this a little. So actually we're going to, the first step is we're going to do some steps here. The first step, we have to make sure that this equation in the standard form, meaning that you have x, y, and z on the left and the number is on the right. Okay? The second step is, after that, is you have to select a pair of equations. So you can't solve the three at once. You have to select only two equations. So for example, we are going to select 1 and 2. Okay? And then you solve for one variable. By addition, okay, you eliminate that variable. Say x, y, or z. That's your choice. So I am not going to force you to eliminate a variable. That's your choice. However, the second step, or the following step, is to select another pair, for example, the second and third equation, but you have to eliminate the same variable you eliminated in the first pair. So again, we put the equation in standard form, we select a pair of equations and eliminate one variable by addition method. We select another pair of the equation and eliminate the same variable. Okay, so now you got an equation in two variables and another equation in the two variables. So now we can solve a system of two variables, and this is what we have learned the last time. Okay, once you get the two values of the two variables, you do back substitution. Say I got y and z. So you can plug the value of y and z and solve for x. Let's get an example and see how we do that. All right. So I'm going to change that. I hope you like this idea. It's a new idea, but it's not related. If you know how to solve a linear equation, you can solve for a system of equations. So far. All right. So I have here 3x plus 4y equals plus z equals 7. Negative x plus 2y plus 3z equals 1. And 6x plus 5y plus 9z equals negative 9. All right. So it's the same technique here. First of all, let's go to step 1. Are all equations in the standard form? Answer is yes. So, check mark. The second step, we're going to take a 2. I'm going to take 1 and 2. I'm going to take the first and the second equation here. So I have 3x plus 4y plus z equals 7. And I have negative x plus 2y plus 3z equals 1. Now, if you think about that, what about x? Can we solve for x? I think that x is easier because if you look at here that 6 is a multiple of 1 and 6 is a multiple of 3. So it's going to be easier. But here it's 5. 5 is not a multiple of 4. So I have to multiply this one by 5 and this one by 4. So I choose x. This is my choice. You may have a different choice. All of them are okay. But I chose x because x is easier for me. Okay? So how can I have 3x here? I need how much x to make that 0? Negative 3x. So now I have to make this one x here negative 3. So I have this negative one, so I have to multiply by 3. So I'm going to multiply the second equation by 3. Let's write the system again. I have here 3x plus 4y plus z equals 7. And then I multiply, so 3 times the negative x is negative 3x. 3 times 2y is 6y. Plus 3 times the 3z is 9z. It's equals 3 times 1 is 3. Now, I am going to use the addition method here and add them together to get rid of my eliminated variable, which is x here. So 3 and negative 3 is cancelled out. 4 plus 6 is 10y. 1z plus 9z is 10z. And 7 plus 3 is 10. Now, this is the first equation in terms of y and z. However, can we simplify this equation? Yes. If you multiply this one by 1/10, or divide by 10, I get y plus z is 1. And this is my first equation. You see how easy that is? Okay? It's a very beautiful equation. Let's do that. So I'm done with here, step 2, and I'll select another pair and then eliminate the same variable. So what's this variable that I eliminated here? It's x. So I will select another pair and I eliminate also x. So I'm going to take 2 and 3 and eliminate x. So let's write them down first. So I have next negative x plus 2y plus 3z equals 1. And I have 6x plus 5y plus 9z equals negative 9. So do you see here why I chose x? So suppose you chose y, okay? You would have to multiply, you have to eliminate 2 and 5. So in this way you have to multiply this by 5 and this by negative 2 to make them 10 and negative 10. But here, all I need is to multiply one equation by 6 and that's it. That's why I chose x and I looked at this 3. 6 is multiple of 3 and 1. 5 is not multiple of 2 or 4. Okay, here z is fine, okay, but 6 is smaller than 9. But it's okay, like z is fine too. Alright, so now I multiply 1 by how much? 6. So I multiply this by 6. Well, let's do that. 6 times the negative x is negative 6x plus 6 times 2 is 12y. Okay, 6 times 3 is 18z and 6 times 1 is 6. Be careful here. Many students forget multiplying 6 by the other side of the equation. Make sure you multiply every term, x, y, and z, and their constants on the other side. Okay? Now, there is no change in the second equation. So 6x plus 5y and 9z equals negative 9. Then, okay, I am selecting and eliminate the same variable. So I'm eliminating that. So I add here, and negative 6 and 6 is 0, so this cancelled out. 12 plus 5 is 17y, and 18 plus 9 is 27z. Now here 6 minus 9, okay, make sure it's a different sign, so that I have here negative 3. Okay, so now I got the second equation here. I have z, y plus z is 1, and 17y plus 27z equals negative 3. Okay, there's two options here to use. Either to use addition or substitution. look at these two. Which one is easier? If you use addition, you have to eliminate y or z, and that would be too much work. But what if we use substitution here? Isn't that easy? Let's see. So I'm going to evaluate z by subtracting y from both sides. So I got here, I'm subtracting y, so z equal 1 minus y. And now this is my equation. Okay? And then I plug z here, so this is going to be 1 minus y and solve for y. Okay? Let's see that. So I have here, I have z, I have 17y plus 27, which is z, again, it's 1 minus y, equals negative 3. Okay, let's evaluate that. 17y plus 27 times 1 is 27. 27 times negative y is negative 27y, and the other side is negative 3. Now let's combine the terms and solve for y. So, okay, 17y minus 27y, this is a negative 10y. And we can move the 27 to the other side. That would be negative 27. So negative 27 and negative 3 is negative 30. I hope that this is clear. So I move the 27 to the other side. That will be negative 27 and negative 3 is negative 30. Then we divide by negative 10 both sides. Divide by negative 10. Negative 10. So I have y equals how much? 3. So now I got y. But I know from here that z equals 1 minus y. So z is 1 minus what is y? 3. So z is negative 2. So now I solve for y and z. Now I have two equations of the two variables. I had two equations and the two variables. It's 1 and a 2. And I use substitution to solve for z and y. And then I use substitution here, so there's a choice, is to use addition or substitution. I use substitution here and I got z. Now we use the two values, which is 3 and negative 2, in solving for the eliminated variables, which is x. So let's try to plug y and z in the first equation. I have 3x, I don't know what x is yet, plus 4y, so y is 3, plus z, and z is negative 2. Let's make that negative 2, okay, which is equal to 7. So 3x, 4 times 3 is 12, minus 2 equals 7. So this is 10, so 3x plus 10 equals 7. So I move 10 to the other side, so I have 3x is 7 minus 10 is negative 3. Divide by 3x is negative 1. So I got x, y, and z. The way to write the solution, open set bracket, and then make the triple pair. It's not pair. It's a triple variables here. So I have negative 1, triple order, and 3, and what is z is negative 2. Question: what kind of solution is that? This one is a consistent. The system is consistent, and I have one solution here. The variables are independent. Okay? Alright, let's get one more example. I hope that this is clear. Let's get one more example to understand the idea. So I have three equations here. I have 9x minus 2y minus 12z equals 11, and I have 2x minus y minus z equals 3, and I have 3x minus 2y, and there is no z, equals 5. Now I need to find the solution of that. Okay, let's start with the first step. Put the equation in standard form. Is everyone in the standard form? Yes. Okay, now we eliminate a variable. I am thinking about y. Why is that? Look, this is 2 and 9 are relatively prime, so I'll skip x. So I'm going to take the first two equations here. 9x minus 2y minus 12z equals 11, and 2x minus y minus z equals 3. Now, how can I get rid of y? I need plus 2y to get rid of that. So I multiply by negative 2. Negative 2. So I got here 9x minus 2y minus 12z equals 11. And I have negative 4x, and negative 2 plus y is plus 2y. Negative 2 times negative y is plus 2y. And the negative 2 times negative z is plus 2z. And negative 2 times 3 is negative 6. Add. So I have 9 minus 4 is 5x. And here is y's cancelled out. And I have negative 12 plus 2 is negative 10z, which is equal 11 minus 6 is 5. So this is the first equation that I got. Is there any way to simplify that? Yeah, we multiply by 1/5. So I got here x minus 2z is 1. Okay, so I eliminated y. Now I'm selecting the next two, and I have to eliminate what? Y also. Okay, so I have 2 x minus y minus z equals 3, and I have 3x minus 2y equals 5. All right. So what's going to happen if I multiply the first one by negative 2 again? So I will write this one, negative 4x, and negative 2 plus y is negative 2 times negative y is plus 2y, and negative 2 times negative z is plus 2z, and then this is equal negative 6. Now 3x minus 2y, and this is equal 5. Okay, add. So negative 2y and 2y is cancelled out. Negative 4x and 3x is negative x. And then I have 2z, and this is equal 5 minus 6 is negative 1. So this is equation 1, and this is equation 2. Okay, last time I used the substitution, but now I see that I can use addition here. So I'm going to put this one, equation number 1, under 2, or add them together. So I have equation 1, x minus 2z equals 1, and equation 2, negative x plus 2z equals negative 1. Okay, so equation 1 and equation 2. Let's add. X and negative x is cancelled out. I have 0. Negative 2z plus 2z. Oh, I have 0. So what about the other side? 1 minus 1 is 0. So I got this one, 0 equals 0. So what should I do? So in this case, this statement is true. Therefore, I have infinitely many solutions. So I have infinitely many solutions. And how can I write the solution here? Well, the solution here is x, y, z, such that any equation would be right. So maybe I write it down here because I have more space. So the solution is x, y, and z such that, pick any equation, 9x minus 2y minus 12z equals 11. And here is my solution. And again, this is infinitely many solution. Thank you, and see you in the next video. I'm going to explain the application. Thank you.